Hi, I'm Charutha, and I'm going to be talking to you about an R&D project I did over the past 6 weeks with faculty on knowing when to trust artificial intelligence. Now, AI can do some incredible things, but the problem is that AI can also fail spectacularly, with consequences on vastly different scales. It can range from erroneous business decisions to racist Twitter bots to self-driving cars causing deaths. So we want to be able to enjoy the benefits of AI without having to suffer the costs of its failure. So the objective of my project was to develop a technique to judge when to trust a model. To explore this concept, I'm going to use a model that tries to distinguish apples from oranges. So during training, it sees images of apples and oranges and learns what they each look like. So if you give it a new orange, it can say, that's an orange. And if you give it a new apple, it can say, that's an apple. But sometimes modeling is just very tricky to do. Say our model had been trained on color and grayscale images, but mostly color, and so learned to primarily use color to distinguish between apples and oranges. Then when it gets a grayscale image of an apple, it has to forget about color and use other features like shape and texture, which are just harder to tell apart. So that can easily lead to mistakes. Another problem is if you give it something completely different to what it's seen before. So if you give it a pineapple, it has to predict something, so it says it's an apple. So models can make mistakes because of either tricky modeling or anomalous input. And we want to know how much to trust a particular model prediction. So faculty has already developed a method to score model predictions on their credibility. And this solves the tricky modeling problem and uses something called a variational autoencoder, or VAE. Now, the first cool property of VAEs is that it creates an abstract representation of our data. So it creates a map where similar points will cluster together. So for apples and oranges, you might get these two clusters plus a grayscale image cluster in the middle. Then faculty's credibility score will be based on the local accuracy. So how many of the nearby points are correctly predicted? So for this orange, because most of the nearby points are correctly predicted, it gets high credibility. But for this gray apple, only half of the nearby points are correctly predicted, and so it gets low credibility. So this system solves the tricky modeling problem, but not the anomaly problem. When a VAE gets an anomaly, it doesn't know where to put it, so there's no telling where it'll land. So if a pineapple happens to land in the heart of the apple cluster with lots of correct predictions nearby, then it gets high credibility, which is not what we want. However, we can use the second cool property of VAEs, which is that it can reconstruct the input. So whether you give it a familiar apple or an anomalous pineapple that gets mapped onto this point, the same apple gets reconstructed. So the trick we can pull here is to compare the input with the reconstruction and see the difference. This is called the reconstruction error, and we can do this by comparing the pixel values of the input and reconstruction. Now, familiar apples will get low reconstruction errors because they will have good reconstructions, whereas anomalous pineapples will get high reconstruction errors because they'll have bad reconstructions. Under the original system, unfortunately, credibility scores of anomalies were misleadingly high. So what I did to fix this was to decrease the reliability of points with high reconstruction error. So what that does is to push the credibility of anomalous data close to zero, as you can see on the right, while leaving the non-anomalous points intact, which is exactly what we want. So in summary, I've developed a technique using faculty's credibility scores in order to judge when to trust AI that's robust to anomalies. So the impact of this work is that you can now confidently act on your predictions, even if there are anomalies in your dataset. So why does this matter? The problem is that after machine learning models are deployed, anomalous data can creep into our dataset. And now that we're all living in anomalous times with this pandemic, it's just more important than ever to know when to trust AI. This will increase efficiency, save us from costly mistakes, and save lives. Thank you for listening.